Was that? Okay. So what I've got is we're working with future value of investment. So we want to know what will be the future value after so much time. Okay. So what we're going to do is we're actually going to change our formula just a little bit, and you can kind of see this part right here. Okay. So that is what. And just take time for the video. That is our compound interest formula. Okay. What we're going to be looking at is we're actually going to be looking at if this is a one-time investment or is this going to be something we continually do throughout so much time. Okay. So to get a kind of little practice with it, we're just going to come up here and say our principal is 5,000. My rate is 1.25%. And then let's compound it. Well, let's do it. Let's compare it. So let's do it semi-annually, and let's leave it alone for 20 years. Okay? So what we're going to do is just fill in our formula. Oops, that should be 2. Okay? So I'm going to pause the video and then put it in my calculator. So if you typed in everything correctly on your calculator, you should have gotten a value of 226,421.46. Okay? It's right up there, sir. It's all good. Okay, so what the future value tells us is it's going to take everything into account as it grows. Okay, so the great thing about this is that as we look at it as a continuation of the growth period, it could tell us what our full potential is going to be. Okay, which is, I think, fabulous because you'd be making all this money like hand over fist. Okay, so let's do a practice one again. All right. So let's invest. Thank you. Let's say you got $1,500. You got $1,500. Let's say you invest it in an account that gives you 3%, right? Let's have it compounded monthly, and let's say that you leave it alone for 30 years. Okay. So there's our formula. Okay. Now, again, there's a couple of you that you need to make sure that if your calculator doesn't raise it up to that power, that if you make sure that you put parentheses around those powers. Okay. Yeah, you just divide it by 0.03 divided by 12. Okay. So then you're going to be working with those sets. If you have to work backwards, you want to do this one first, raise it to its power, subtract 1, then multiply by the principal, then divide it from here, okay? So that's what we're looking for. Now, yeah. So what happens with this is, let's see here, let's just make this years. 87,004. Oh, I put the comma in the wrong place, didn't I? How's that? Okay, so what happens is if we start just to compound it once, okay, so n is equal to 1, that's what's going to happen to our money, right? If we start compounding it more, you're going to get larger growth, okay? Even though at this point, what we've been looking at with the other stuff that we've been working with, all our data sets are going to be pretty close to this, all right? But as long as you leave it in the account longer, you're going to make more money, okay? So the idea is when you do an investment, it's something that you're going to leave alone for more than 5 years, okay? And if you start investing now and you leave that account when you guys retire, you'll have plenty of money to retire on. But you got to leave it alone. It depends on what you want. With the way inflation is going, everything like that, I don't think $1 million is going to be enough for you guys. Okay? So, let's